So to summarize this part, we found that when a rod moves in a region where there's a magnetic field that's constant in time, it doesn't change with time, but the rod is moving on this rail, there's a potential difference set up across the ends of the rod equal to BLV wire. And we calculated the EMF in this loop as if we were calculating the EMF using the same formula we had before, rate of change of magnetic flux. And the strange thing is that using this formula that we took before, rate of change of magnetic flux, we get exactly the same answer. And that's not a coincidence. And in this case, the magnetic flux is not changing because the magnetic field is changing. The magnetic field is not changing with time. It's always the same value. The magnetic flux is changing in this problem because the area is changing. But it turns out that if you use the same equation for EMF, meaning if you get the rate of change of magnetic flux, you get the EMF, which is the same equation as the case where the wires are fixed. So it's a very interesting result. So it turns out that when you have the wires moving and the magnetic field is not changing with time, you can still use this equation to get the EMF in the circuit. Now the EMF in the circuit in this case is not integration of E dot ds around the loop. You can't use that formula anymore because that formula was only valid when the wires were fixed. So this still represents the EMF. If you go around the loop, you integrate the force per unit charge going around the loop, you still get it's the EMF, right? But it's not, the EMF is happening not because the magnetic field is changing with time, it's happening because the area is changing with time, because the wires are moving. And so this is a bit subtle detail, but the nice thing is for us in the course that you have exactly the same formula, that the EMF is minus d phi by dt. So you can use the same formula for both kinds of problems. And once you know what the EMF is, then the circuit becomes just like any other circuit. You have a resistor, you have an EMF, a source of EMF, and you can then get the current in the loop. It's the EMF over the resistance, which is BLV over R.